Thank you, Jason, and thank you very much to the organisers of the MSEAS for inviting me to provide this talk. Mark just mentioned the World Fisheries Congress, which took place in South Korea last week. And my co-chairs and I agreed that it would be a great idea to submit a session proposal to this conference to discuss the topic that you see here, how natural scientists and social science research can be better used for policy. Clearly, there are some parallels between the discussions that we're going to have here today. And we've seen in some of the earlier talks that there's been a much increasing demand for the need to integrate the natural and social sciences. And so this was the topic of our session. And we had some specific questions that we wanted our speakers to consider, which I'll allow you to read here. But they're really about how natural and science advice can be better used in policy, what kind of advice is required, how do natural and social science products, what kind of products are needed by communities and stakeholders? And one of the questions we wanted to ask is that we're all, I should actually just acknowledge my co-chairs, Leon Campling from Clyotop, Alan Haney, who's here today also, Jorn Smit from Kiel, and Misutaka Makino from Pisces, who's not here. We all represent large global science programs, and the idea was also to investigate how these large science programs can include the natural and social dimensions into their work. So coming back to this then, one of our considerations was how can we do that, and are these large scientific programs a good platform for such advice? What kind of improvements do we need and what's required? So this is kind of our background. We thought it might be useful to bring some of our discussion from that meeting here, since again we're talking about similar issues, and we have some key salient points that we want to bring to you. A very quick synopsis. We had about 21 papers, and we've talked about scales very briefly. I think Jake mentioned it. And these papers were focused at different scales, so sort of the large-scale global papers, regional, national levels. And then we had a whole series of about 9 much more specific case studies. What I've tried to... Okay, what I've tried to do in the left-hand column... is just to point out whether these were projects that were started by natural scientists and then started to include the social sciences over time. So IMBER, which is the Integrated Marine Biogeochemistry and Ecosystem Research Project, which I'm involved in, did, and also NOAA, as we've learned, is including more sort of social dimensions. Projects that started with the social and added the natural. So there's a project here, which I'll come back to later. Those that started off with both, and then those that are really just social sciences, and that applied to a lot of the case studies here. And again, I'll come back to that. We had a couple papers on modelling, which tried to include the natural and social sciences, and I'll come briefly back to those. And then we had a couple papers, one which really was from a theoretical approach by Dorothy Dunkel, who's also here today, and one which by Stuart Frugier, who's also here, sort of reflections on does interdisciplinary research play. So you see about the range of papers, and as I say, I'm going to try and distill the key messages and discussions around those. Just popping this up briefly to say that many of the papers approach this from a socio-ecological systems perspective, again, which we heard of from Serge earlier on today. This was from a nice paper by Iriana Vagipoulos, who's Greek working in Japan. So we picked out about 8 what we called salient points, and I'm just going to go through each of these over the course of the next few slides. I'm not going to read them out now because you're going to see them all again. So the first one was this whole idea of fisheries as wicked problems or as post-normal science. These 2 different terms were used by different papers in the session, and I think we concluded that they both mean the same thing. So by wicked problems, and this is a term that's been used by Yentoff and Chung-Pagdi, for example, and in a paper by Chung-Pagdi, she defined wicked problems as problems that are difficult to define. They have a social aspect, scientific aspects, and there's no formula, no stopping rule, no solution. Every problem is novel and unique, and mistakes are costly, which describes fisheries governance. And then the paper by Dorothy Dunkel, she described this as post-normal science. And so we started off this sort of sequence of science over time, and I think Serge pointed to some of this, or it might have been Jake. I'm getting my people muddled up now. So we had a sort of very applied science beginning, and then as we move through time, we get into this post-normal science. And post-normal science is described as situations where facts are uncertain, values in dispute, stakes are high, and decisions are urgent. And I think we can all agree this also this is very key to the decisions that are made in fisheries. So again, several papers pointed to the idea of the need for a transdisciplinary approach to both fisheries science, but ecosystem-based management in general. And I think that's the message that we've had coming through the papers this morning. And we had several papers that addressed this directly. We had different, again, terminologies and perspectives on this. Sort of, there's no solution, only resolution from the Too Big to Ignore project. And we looked at integrated solutions and a terminology which I was unaware of, responsible research and innovation, which appears to be a parallel approach to sort of co-design, co-production, which is a big future Earth speak these days. So lots of terminology, but an agreement on the whole transdisciplinary approach. And this is just a slide from Jorn Smith's presentation, which shows how this can be defined through a project. So this is a co-design, where you have a joint framing and research definition, and then co-production of knowledge, where you look at the science of integration and relevance, and then at the end, a dissemination of results. And during different stages of this, there's a different level of involvement between the sort of stakeholder involvement and academic involvement. All right, and that brings you back down to the co-design, because this, of course, is an iterative process. Okay, the second salient point, which is all about this idea that, and I tried to point that out in the first table, we're often in the case where we've got big natural science projects or programs such as ICES, PICES, NOAA, DFO, and we're always starting off from a natural science perspective and saying, hey, we need some social science in this. And when we start with the natural sciences, the social sciences are also often the cream on the icing on top of the cake. And the suggestion is that we need to be much more integral in design, as I've just shown, in a transdisciplinary approach. And the cake has to be planned out from the beginning, and all those different kind of disciplines and aspects brought into the original design. Some suggested that this shouldn't be a tiramisu because it's too linear, and we need something that's much more circular or non-linear. But then, I don't know, tiramisu, the flavors all mingled, and I think by the time it gets to your taste buds, they're all mixed up in non-linear anyway. Anyway, and the question is, should social scientists, should we be addressing these questions, starting them from a social science point of view rather than the traditional natural science view as we have done in many cases? And several of the case studies, in fact, most of the case studies that were presented at this meeting indeed started from that point of view. And I just want to talk about one just very briefly. And this is a case study from Yinji Li, who's a member of the IMBER Human Dimensions Working Group, and at Tokai University, on a particular case study from Shizugu Bay in Japan. There's a picture of it there. It's a very small bay, about 40 kilometers squared. There are 4 different fishing communities with fishing cooperative organizations or associations. It was very, very intensely fish farmed with aquaculture, with about 5 different types of aquaculture, I think. And then they had the great Japanese earthquake, the tsunami that was all wiped out. And then all 4 communities started to rebuild. One of those fishing communities, decided not to do the intensive farming, but to cut back the number of cages, to simplify their operations, and go for high-quality product, rather than the decreasing productivity that it had under the old regime. So she went through this in quite a lot of detail. It's a very nice study. And they came to the conclusion point that for these people, that one community where they'd actually backed off on the high intensity, they saw better sized oysters, they saw higher productivity, and basically they were benefiting from their returns. And now they're asking the questions, okay, we need some science advice now too, and it'd be good to get an estimate of the carrying capacity in that bay, and look at sort of optimum production levels. Also, recognizing that given it's such a small bay and there's all this intensive aquaculture going on in these other 3 operations, it may be in the longer term their productivity will decrease again because of the other operations. So there are some scientific issues, but as I say, it was started from the social science aspect. All right, the scale myth. How many times have you heard that the social sciences focus at the small scale level and that the natural sciences are large scale? I borrowed this slide from Ingrid van Putten, who borrowed it from Melbourne Thompson in the paper in prep. But this is a really neat slide, and I like it because what it's showing you is that here we've got scale from the individual to the global scale. Here are different kind of physical discipline groupings, so from the physical, ecological, economic, socio-cultural, and management. And the fact is that all these different aspects of the system have aspects that occur at all these different scales. So small scale is not particularly relevant to the small social sciences, and large scale is not particularly relevant to the natural sciences. And this is a couple of examples then from some of the papers that were shown. This is from the Too Big to Ignore project, which is developing an information system on small-scale fisheries. So all those dots from all over the globe is information that's collected about small-scale fisheries. So even though each point the data is collected locally, you can synthesize that over a much larger scale. And that's essentially what we do in the natural sciences. We have catch data from different ports, and we synthesize that overall. Another project from the NERIAS program, they have both the global scale and the local scale. And so I'd like to just sort of propose this, that there's a myth about scale and the different levels at which our different sciences operate. They operate at all scales, and it's important to recognize that. With a sort of caveat, and this is something that came out of Jorn Smith's presentation, is that often it's not a question of spatial scale, but the kind of scale of the issues that communities are interested in may not be the same scale that the scientists are interested in. Okay, integration, transaction costs, and project evaluations. A couple of papers talked about the fact that integration takes time. This is from the US Cost Action Oceans Pass platform. And this is from Alan Haney, who's here in the audience somewhere, talking about the Bering Sea project. And integration is hard. I mean, we've talked about it all this morning about the need, but it's a hard thing to do. And his recommendations from this project was that you need to do it early, you need to do it lots, and if you think you're doing enough, you're probably not. And integration needs to be a driving force of the project. There are also transaction costs in the project, and one of the things we talked about was that many large-scale projects have, different working groups focusing on different things. Here's a couple of different examples. It's vital that these working groups are in communication with each other throughout the whole project. Otherwise, you meet once a year, you all go off to your different things, come back another year, and you've gone off in different directions, and there's no communication between you. Also, sometimes there are one parts of projects that are dependent on other parts, and that can create problems down the line if one part of the project's not able to meet its goals for whatever reason. And just to point out here, the communication education part of this project, this is the Gulls project with the Brazil hub, is specifically targeting on taking that science to the policy level. I'll come back to that. So, I think I've just said all that. Another key important suggestion that came out is that when there's very little project evaluation in proposals. And so you have to know what works and what doesn't work, and how that might inform future projects. So the evaluation, particularly when you're dealing in a transdisciplinary project, is key.
Alida, 5 minutes.
Oh, really? Okay.
Yes.
So on the changing... Just quickly then, on the changing role of natural scientists, I think, again, from presentations, we can't be the natural scientist who sits in a lab and is not aware of the broader implications of the research. And I would suggest it's the same for the social scientists and economics scientists. We have to be more aware of the broader integrated world that we're now living in. And just as a little bit of tongue-in-cheek here, we often hear natural scientists looking for social scientists to engage in their projects, but it's not so often that's turned around where you see social scientists saying, hey, we really need a natural scientist on this project. Just quickly, this was a couple of things that came out on the idea of responsible modelling, and since we're going to be talking a lot about that during this conference, I thought it'd be worth picking that up. So Dorothy Donkel, who you can ask about this, came out with a statement that what if all models are wrong, and there's issues about who owns the model, what are the owner's interests, is the model proportionate to the task, it's used to obfuscate or illuminate, etc. And then again from Alan Haney, looking at models, we have to be careful not to make naive projections, and ensure that the messages are properly understood. And I'll skip the rest. So just some caveats on modeling there. the whole issue of how well can we incorporate our science into policy. This is from both the natural and social sciences perspective. And overall, I'd say that there was less focus on this. And I did ask a few times during the session, asked that a question, how is this advice used in policy? And again, there seems to be a gap between the science and the policy. One nice example where actually science did inform policy was the input to the FAO small-scale fisheries guidelines from the Too Big to Ignore project. Most research programs do work to influence policy, and for example, Nereus had some key suggestions as to how to improve that in their own project. But as I say, we didn't get as far with that as we'd hoped, I think. And so the question is, there's a bit of a mismatch between what scientists think policymakers need and what policymakers think they need. So there's a communication challenge here, which I think we need to be aware of. And as Makino-san pointed out, there's lots of studies about fishermen's perceptions, but have we studied policymakers' perceptions and what they need? I just got a couple more slides here. Oh yeah, so how can I should say I've cobbled this together over the last 2 days en route from South Korea, so apologies if it's a bit incoherent. How can different types of scientists influence policy? So for example, I'm a government research scientist, so there's a limit to what I can reasonably do under my mandate, whereas academics generally have a much broader role that they can play, but then I might have more direct influence on at least fisheries policy perhaps than an academic might have, and we have these different roles. NGOs have a role, consulting firms have a role, community practitioners, etc. And I think we heard a little bit about this in previous talks too. There's a much broader people of their range of experts out there that can input through the process. And just to note again that transdisciplinary research means going beyond just across and beyond, means going between and across and beyond disciplines, and also across different types of scientists. We have to bring different communities in this. Finally, one of the motivating factors for us to hold this session was to ask, is there a need for some sort of research forum or communication network for interdisciplinary research? Because progress is happening and it's happening quickly. This is a slide from Stuart Fruger. And he just pointed out all the sort of different aspects just happening right now in a sort of integrated interdisciplinary science. Oops, that's one I want. And this is something that we added this morning, that there's also within countries growing national integrated social science going on. But how well is it all coordinated? And so here again, talking from the large science program perspective, really we need a greater communication. And happily, this, I guess this conference is an example of that, where we can share shared interests and understandings of how we approach, the different aspects of integrated management, ecosystem-based management together. And clearly, there's several shared focus areas. Then this is honestly the last slide. Just a couple other points that we felt were worth noting is that science that will be relevant for people almost always has a strong development component, which requires engagement not of only people and scientists, but also practitioners and institutions. We need to develop new methods and innovation. Innovation wasn't a word used too much, but innovation is required to get to the next level of thinking for sustainable oceans. The idea that sometimes it's controversial issues or disasters that are catalysts for action, such as in the case of the aquaculture in Shizugawa Bay that I showed you. And often having issue-based research can be a key driver for integrating the natural and social sciences. So I'll stop there. Thank you.